Welcome to Bite-Sized Data Science. I mentioned Spark a few times in previous videos. To me, it represents the start of popular data science. This is not because it started data science, it just popularized it. Just like the popularity of object-oriented programming started with C++, despite the fact that languages like Smalltalk had been around over a decade earlier. So, data science was around before, but less accessible. Spark appeared on the scene in the peak of the big data craze, for lack of a better word. Hadoop was supposed to be the king of the hill. The Spark open source software arrived and claimed to be able to process data 100 times faster than Hadoop. Since Spark is a processing engine and Hadoop is a data repository, it made sense to incorporate Spark in the Hadoop environment. So, Hadoop needs Spark, but Spark does not need Hadoop. It needs access to data, which could be from a Hadoop HDFS file system or a distributed file system, for example. This means you can find Spark in many environments without having to worry about managing a Hadoop cluster. It is a matter of choice. From that point on, Spark took off with a huge following and a very active community. New releases came out quickly, and new functionality was added with the help of multiple commercial companies. The main functionality added on top of the Spark core are SQL, streaming, machine learning, and graphics. What is Spark? It is an analytics engine that supports massive parallel processing. That does not mean it must run on a large cluster. It depends on the amount of data and processing you need to do. In fact, Spark can run on machines from laptops to large clusters. It also incorporates capabilities that allow it to recover from node failures. This starts from its main abstraction, the Redundant Distributed Dataset or RDD. An RDD represents a dataset. The data can come from the local file system, HDFS, databases, and more. You can operate on the data as a whole even if the processing is distributed over multiple processes and machines. This way, we can think about the processing and not about the mechanics of getting data from multiple places. Over time, new abstractions were created so optimization could take place under the cover without the programmer's interventions. These abstractions are data frames and datasets. Both data frames and datasets are related to Spark SQL. We'll talk about that later. You will likely spend most of your time with Spark using data frames or datasets. Spark supports multiple programming languages. They are Scala, Java, Python, and R. Since Spark is mainly written in Scala, it was the preferred programming language in the early days. Scala compiles into Java bytecode, so Java is also a native language for Spark. During the first few years, if you wanted performance and the latest functionality, you were better off using Scala over, let's say, Python or R. Over time, Python especially gained in popularity. The feature set eventually became at par with Scala. Today, Python is likely the most popular language for Spark. Do you need Spark to do data science? You can look at it two ways. First, if you have a huge amount of data and need a cluster to process it, Spark is the right answer. In other cases, the data you need to process may actually fit in memory on a single computer. Still, you could possibly save money by using a cluster of smaller machines, so Spark would fit well there. There is another reason to use Spark regardless of the amount of data you need to process. Spark can provide a standardized way to process your data. You can have your entire team use Spark as their primary processing engine to limit the number of products that must be learned. Of course, it is unlikely that your organization would use Spark exclusively, but at least it would provide a common ground for the team members. Am I saying you should use Spark? No, but if you need reasons, you now have them. In the next video, we'll dive deeper into Spark to get a better understanding of how it works. See you next time on Bite-Sized Data Science.